Solve the system of equations by the method of substitution. In our previous video, we looked at a couple of examples of solving by substitution, and we reinforced those by graphing the two equations in the system and finding the common intersection point, which was the solution to our system. We're not going to do the graphing part in this video. We're just going to concentrate on the steps required to find an intersection point, if there is one, using method of substitution. Step one, look at your system of equations. Think about the variable that would be the easiest to isolate. In my opinion, the x from the top equation would be the easiest to isolate. X minus y equals 4. If you add y to both sides, x equals y plus 4. Then in step 2, you go to the other equation and you substitute x with a y plus 4. 6x, replace your x with y plus 4, minus 5y equals 28. Distribute your 6y plus 24, minus 5y equals 28. 6y minus 5y is 1y, plus 24 equals 28, so y equals 4. Then for the last part, you go back to step 1 and you replace in the number that you just solved. Y equals 4, so 4 plus 4, that gives us x equals 8. Carefully pair your x and y. 8, 4 would be the point of intersection if you were to graph these two equations. The second system of equations, we have 2x plus y equals 7, 8x minus 7y equals 61. When you're looking at your variable terms, I think that the top y is the easiest to isolate. So in step 1, 2x plus y equals 7, I subtract 2 x's on both sides, and that gives me y equals negative 2x plus 7. In step 2, you go to the other equation and make that substitution. The second equation, if I replace y with a negative 2x plus 7, that's just going to take the place of y. 8x plus 14x minus 49. 8x and 14x combine for a 22x. Add 49 to both sides. That totals 110, divide by 22, and we get x equals 5. That'll be the first number of the solution point. Go back to step 1, replace x with a 5, so that's negative 2 times 5 plus 7, that's negative 3, and your y value finishes the pair. Use the equations for the total cost and total revenue to find the number of units a company must sell to break even. Revenue is the money that is made by a business or a person. Cost is the money that goes out. It's what's required to pay your labor, pay for supplies, and all that. Where you break even is when the money coming in is equal to the money going out. Long story short, set your revenue function equal to your cost function. Solve for x, subtract 8,600 from both sides. 908x equals 270,000. Divide by 908, and if it doesn't come out to a whole number, just round to the nearest whole number. For this one, that's 297 units. A company invests $16,000 to produce a product that will sell for $47.85. Each unit costs $7.40 to produce. Let capital C represent the total cost in dollars of producing X units. Write an equation for C in terms of X. Cost, that's money that's going out, not, it's what your cost for selling something. So $16,000 is the initial investment. It costs $7.40 to produce each item. So your total cost is going to be $7.40 per item, plus the $16,000 is the initial investment. Capital R is revenue. That's the money that will be coming in due to sales of a product. They're going to sell for $47.85 each, so your revenue will be 47.85x. Money going out versus money coming in. Let P represent the profit in dollars when X units are produced. Write an equation for capital P or profit in terms of X. So for profit, you take your revenue minus your cost. Revenue was 47.85x minus your cost function had two terms. Be very careful here. You have to distribute the minus sign to each term. 47.85 minus 7.40 minus 16,000. Combine these two like terms, you get 40.45x minus 16,000. That's your profit function. How many units must the company sell to break even? You can calculate this one of two ways. You can either set R equal to C, where revenue and cost are equal. We did that on the previous example or slide. Or if you have a profit function, that's where profit equals 0. You pick which way. If you do it right, you'll get the same answer each time. I'm just going to use the profit function from above, set that equal to 0, add 16,000 to both sides, divide by 40.45, and we get approximately 396 units. If those are sold, then the money coming in will have equaled the money going out, including initial investment. How many units must the company sell to make a profit of $115,000? Again, take your profit equation, replace profit with 115,000. Solving for X, we add 16,000 to both sides. 131,000 equals 40.45x. Divide by 40.45 on both sides, and you get approximately 3,239 units in order to make a profit of $115,000. You are offered two jobs selling college textbooks. One company offers an annual salary of $53,000 plus a year-end bonus of 1% of your total sales. The other company offers an annual salary of $50,000 plus a year-end bonus of 2.5% of your total sales. How much would you have to how much would you have to sell in a year to make the second offer the better offer? Offer one starts out more, but their bonus pay is less. So let's see. Offer one, $53,000 salary, 1% on sales. The other company, $50,000 salary, 2.5% sales. Be careful to convert your percents to decimals by dividing by 100. Take your number, divide it by 100, or just scoot your decimal place left 2 spots. I'm going to go ahead and set these even, equal to one another, and see what the total sales would have to be for them to be equally offered. Each offer to be equal. Sorry, I'll get it out here in a minute. Okay, so offer one equals offer two. Subtract 50,000 from both sides. Subtract 0.01x from both sides. Dividing by 0.015, we get $200,000 in sales. So at $200,000 in college textbook sales, the offers would pay the same. Anything more than $200,000 in sales, offer two would be the better one. Uh, I do want to kind of fast track you on these types of problems. Uh, the difference in the salaries is $3,000. The difference in the bonuses is 1.5%. If you come back down to this line, it's the difference in salaries divided by the difference in bonuses. That's the fast track. Find the length and width of a rectangle with perimeter 52 meters and a length that's 4 meters greater than the width. Perimeter of a rectangle, you have to travel the width twice and the length twice to go all the way around. We don't know the width or the length, so we're going to say 2 widths plus 2 lengths, with length being 4 greater than the width that was given in the description. Perimeter is 52, so we replace P with a 52. 2W plus 8, combine like terms, that's 4W. Subtracting 8 on both sides gives us 44 equals 4W. So the width has to be 11 meters. We can go ahead and say the width is 11 meters. Since the length is 4 meters longer than the width, 11 plus 4 is 15, so the length is 15 meters. Our rectangle is a 15 by 11 dimension. The cost of producing X units and the revenue obtained by selling those units are shown in the figure. The cost function is the red line and the revenue function is our blue line. Estimate the point of intersection. So in class, you guys said, well, the X value is about 2,500. That's accurate. The Y value, if we come over here, that's halfway between 100,000 and 150,000. So that appeared to be 125,000, and we all agreed on that. So our point of intersection is 2,500, comma 125,000. What does this intersection point represent? Well, when revenue and cost are equal, that's the break-even point. Use the figure to estimate when there will be an overall loss, and then use the figure to estimate when there will be a profit. Loss is when your costs are more than your revenue, and profit is when your revenue is more than cost. So I'm going to scroll back up. Revenue is more than cost after 2,500 units are sold. There's going to be a loss because the cost outweighs the revenue before you get to or less than 2,500 units sold. So it really does revolve around the break-even point. Overall loss is when sales are less than 2,500 units. Profit when sales are greater than 2,500 units.